And we're live. We're only 6 minutes late. That's not bad considering everything else has been going on in life these days.
Yeah, absolutely.
So, good evening. We're here, Andrew and I, here just to chat a little bit about potential severe weather setup and, of course, storm chasing for tomorrow, which is Wednesday. Good heavens! I guess that's the 27th of June.
June is flying by.
It is. It's almost done with. And of course, what's right on the heels of this particular setup, of course, is a heat wave coming in behind it.
The typical June weather.
Yes, it is. And
I mean, of course, July weather, sorry.
July weather, right. But actually today, we've been rather atypical, having a late June wedge in place with this front that sagged south of us. And I don't know about you and Darren Richmond in Roanoke here. I think we barely touched maybe 71 or 72 today.
We were in the upper 70s, but it was you could tell it was a very cool, damp 70. The sun would come and go at times, so it wasn't like a socked in wintertime wedge by any means, but it was noticeably cooler, but a welcome relief.
Right.
For the most part. And
I think that this wedge is going to play a big role in what happens or what may not happen tomorrow. You know, as we both know, and I think everybody who ever paid attention to models know that the models never handled the wedge leaving very well.
No, not at all.
And so I think that's part of why SPC is being a bit cautious, and then the National Weather Service offices here in Virginia that I read their discussions on, they're being a bit cautious about tomorrow too, because they don't expect the wedge to get out as quickly as some of the models are predicting. Of course, which would mean less time for destabilization and that kind of stuff to happen. But we can certainly chat about it. And let's see if I've got my screen share set up here. I can set the stage.
Yeah, I would say we know all too well the perils and battles of chasing the wedge around here, and how it can make or break your chase depending on which side of the wedge you wind up chasing on.
Amen. Amen. So, can you see this graphic?
Yep, all good.
All right, so this was this morning's SPC Day 2 convective outlook. And you can see that it's got just basically a broad brush for marginal risk that barely gets over east of the Blue Ridge Mountains here in Virginia. I thought that was a little pessimistic. And when they came out with their later or midday, they did move it to the east a bit, which is basically right along the Route 29 corridor now. If the models continue to hold like they are, and of course, I haven't seen the 0Z models. They're just now coming in, and we'll have to take a look at those. I would expect that line, the right side of that marginal risk line, might move a little, maybe another 30 to 40 miles east, and it may very well introduce a slight risk over there somewhere, say from the Charlottesville to Beckley, West Virginia, down to the southwestern corner of the state, because the dynamics over there, especially from like the I-64 corridor, the dynamics look pretty good. So to talk about that, here's at 21Z or 5 o'clock tomorrow, here's the GFS's representation of the 500 millibar winds. That's not bad for June.
No, not at all.
That there's a surface low, and of course you can see the trough there crossing the Great Lakes, and that lobe of say 30 to 40 mile an hour plus 500 millibar winds is extended fairly far south down into North Carolina along the mountains. So, and it covers, as you see there, it covers a good chunk of Virginia, actually over to your neck of the woods there at Richmond.
Yeah, we're sitting on the fringe.
Sitting on the fringe. So that sets the stage for some decent shear to be available for any updrafts that go up. And here's the 21Z moisture, or I'm sorry, dew points, surface dew points. You see the moistures won't be a problem. You know, once this wedge, which actually will be a warm front tomorrow, once it lifts northward, the dew points will surge in from the south. So the question will be, A, how fast will the wedge depart that warm front, and B, whether we'll get any sunshine to help destabilize things
Mm-hmm.
behind that. And then here's again, the 21Z, 5 o'clock tomorrow. Here's a look at the shear values, and of course the most unstable Cape as well. But shear values are looking, as you go northward in Virginia, you're 30, 35 knots. So that's not bad. Certainly not great, but it's not bad for this time of year.
Yeah, it's better than 10 knots, which we'll sometimes typically see around here.
Yeah, especially once we get into July and August, when Virginia, Mid-Atlantic is where the fronts come to die. So, and I think that was it. So let me stop sharing this here. Here we go. So that just kind of describes the general setup for tomorrow. I do think they're looking at, and I can pull up a screen here in a little bit, looking at some of the models. I looked at a number of the models, short-term and long-term, and the WRF models I looked at from this morning, the 12Z runs, were generally showing a line of convection making it over to the 95 corridor probably by early evening tomorrow, like 9-ish, something like that. So I think you could probably see in your neck of the woods some storms approaching on the western edges of the Richmond metro area, probably by about dark.
Yeah, that's kind of what I'm seeing just from my perusing. The 3K NAM is very, very pessimistic right now. It just doesn't want to get anything firing. It seems to be battling a little bit with some convective inhibition, but if I look at its forecasted reflectivity tomorrow afternoon, I mean, it barely has anything firing. A couple of little small cells firing in the Stanton to Lexington region, but they just nothing sustained at all. If I was basing my chase day on this model alone tomorrow, I wouldn't even be considering it. But you're right, the WRF models are way more advanced or bullish on the storms firing and sustaining and moving east, towards the Richmond area by nightfall. I mean, the 3K NAM has decent dynamics, kind of the same thing as you were pointing about 30 knots of shear, decent instability in the area, pushing 1,500, 2,000 joules.
Yeah.
So nothing to jeer at. I'm just thinking, I'm guessing it's picking up on some kind of a capping inversion or something that's preventing storms from really firing. I'll pull up some soundings here, or forecast soundings, and see if I notice any kind of nose or anything that's lurking in these areas. But let's see, Valid Tuesday. Unfortunately, when you pull them up, it pulls up the current time you're looking at it.
Of course it does. Yeah, I noticed that the 3 kilometer NAM has been, the last couple of setups has been a little pessimistic, like is probably the way you put it. And I'm wondering if it's not. I mean, typically the NAM overdoes moisture.
And it has the front retreating. I mean, it has mid-70s dew points almost all the way up to the Maryland-Pennsylvania line. So it's, I mean, again, where's the front actually going to set up? It has it, storming northward with no problem. But I get a little nervous when I see models taking the wedge and moving it that fast. But
right,
if there's one time I'd like to be proven wrong, it's now that the wedge front is not stubborn and will actually retreat.
Exactly. The one thing I did not check, which you might do for there in Richmond, is the 700 millibar temperatures. It may be pulling in some warm air aloft on the 3 kilometer NAM. I don't know. But you probably have to look at the regular NAM for that.
I'd say the 3 kilometer does have a 700 millibar temperature. This is looking at 0Z. Yeah, it's pushing probably 9 or 10. So that's
pretty strong for here.
Yeah, that's not, without strong forcing, that's not really what you want to see. In hopes that storms might be able to overcome that. If if a potent cold front was coming through, then that wouldn't be a problem. But without a whole lot of forcing, that could be a tough thing to overcome. But if 700 millibar temperatures aren't that high, and I didn't look at the WRF to see if it was running lower,
right?
I don't even think the Wharf has 700 millibar temperatures. At least not that one. Let's try another one.
Yeah, not the ones I look at. I just pulled up the GFS, and it looks like it's running 8 to 9 in that same neighborhood. So that may be the mitigating factors. It may be capping things over that way. Again, I was looking at 21Z tomorrow. I'll pull up a sounding here and see what it's talking about. Let's see. You're talking about, well, it's it's below 10. And they're talking, this GFS is talking, if you could believe it, surface-based CAPE over 4,000.
That seems, that's one of the higher numbers I've seen around here. I don't often see the high resolution models get that high around here. It seems like they love to cap out around 2,500, 3,000, unless it's a super juicy setup. But
right,
I would venture to say that's probably on the bullish side.
Yeah, and of course, I think the GFS has got the dew point at 77 tomorrow, so that might be a little high. But the wind profile looks pretty good because it backs all the way around the southeast of the surface. And of course, the little potential hazard type over there, it does indicate tornado right in your neighborhood.
Yeah.
So if with that kind of CAPE, if that was true, then I might believe that. Because, you get that much CAPE, it could create its own shear sometimes by just pulling in, low-level air.
It doesn't look like the Wharf models on Pivotal Weather have any soundings attached to them, so I can't pull up any, at least not the one I'm looking at. Let me see if I can pull it up on another. No, it doesn't look like it.
I haven't seen those. The Wharf, the ARW might. That has a few more fields, but I haven't looked at that for a little bit. Let me see here.
Yeah, it's just static on it. It's only got the severe weather parameters, and unfortunately with the HRRR, we aren't in range to see that far out yet. So
yeah.
But yeah, if the GFS is, I wonder how quickly. Let's see how quickly that has the front retreating out of here. I'd be curious to see when it has it coming out of here. Let's see, 0. Let's see. Let's go to the 18Z. As much as I don't like the off-hour model runs,
they're getting better though.
They're
using a lot more satellite data to pull in profile work.
I mean, it's got by 0Z tomorrow. It's got low 70s dews all the way up to the Virginia Maryland line.
Right.
It's just jumped on me. It's kind of uneven how it's bringing it in. It's kind of, it seems like it's eroding from the southeast, and it's keeping, kind of a mid 60s out your way in the Roanoke area. So usually, I mean, unless it's the dead of winter, the wedge doesn't like to erode that way. I feel like it usually tends to erode from the southwest and northeast. So, if that's holding true, anything that fires would probably start really elevated out your way, and then as it clears the wedge and gets into these higher dew points to the east, they may start becoming surface based.
Right. Right. Let me share this. This is the Wharf model, the ARW for reflectivities for tomorrow at 0Z, and you can see that there is a line there, kind of approaching Richmond from the west. If we back it up, I'll back it up here, and this is at 09Z. You can kind of start seeing the wedge. The warm front, crossing Virginia from west to east, but then you also do have, like you're talking about, from the southeast, you have the moisture building up there too, maybe kind of along the bay. But I think that's probably not a justification, but a verification of the wedge retreating, and then you got things crossing the Blue Ridge about 21Z tomorrow, and then starting to fade out as it goes further east, probably just because of the lack of diurnal heating. But
the one common factor I am seeing between these models is wherever the warm front is setting up, something is latching onto it and going to town. There's been one strong cell showing up either around the DC area or further north to the Pennsylvania border, and that's roughly where, based on the dew points, that the wedge front would likely be setting up, and it's picking up on something, trying to latch onto that and surviving onto it for a little bit. I mean, that's basically what you saw down in Lynchburg
Right.
the other day.
Yeah, that's. I was thinking too that we should have probably done one of these like last Thursday night, but that was right after our the night after our previous video con on the Chaser conference. So
Yeah.
but yeah, because I was totally prepared to chase that on Friday, and the setup happened just about like I thought it was going to,
Mm-hmm.
with the wedge front lining up along 460, and I caught that single cell or discrete cell out ahead of the line that was headed toward Lynchburg.
Mm-hmm.
Boy, I tell you, that wall cloud underneath it was going to town while I was watching it. And
Yeah.
then it hit the front, of course, and then made that right turn, and they fired off a tornado warning. But even Robert Stonefield from the Blacksburg office mentioned, apparently he was the one that fired off the tornado warning, and he mentioned that it was kind of like you kind of had to, but there really wasn't enough 0 to 1 kilometer shear to make it happen.
Mm-hmm.
But because of all the other parameters, it was like, yeah, we better do this.
Yeah, because you never know what little storm scale environment might, especially being around some mountains, you never know what kind of surface wind might catch a mountainside and just create that little extra oomph you need to.
Right.
I mean, it would be weak and brief, but would still be something. And if you didn't warn it, then people are going to criticize you. I mean, kind of damned if you do, damned if you don't. But
yeah, that didn't help their false alarm rate, but that's all right.
No, and I think that's kind of the nature of storms here in Virginia. The tornadic storms are so few and far between that I think if you only did it every once in a while, people would just kind of forget that they even happen and not know what to do. But as much as you hate having false alarms, sometimes I think it's good to keep it in people's minds that tornadic storms can and do happen, and just always take your safety precautions, really no matter what, because we've seen before tornadoes here spawn up really fast and they can do some quick damage and then they're gone in a matter of minutes. So.
And that was a classic setup for if you look at tornado climatology for Virginia. Obviously, there's the peak is like April, May, but there's a secondary. I call it a peak, there's a bump about like July, and what I attribute that to is when talking about where fronts come to die. These frontal zones come in and just kind of die over Virginia, but they leave just enough shear that if storms fire, they'll hit them and they'll spin up real quickly, and they'll spin out a tornado. So that's essentially what happened last Thursday. It was just there was a bit more dynamics available than it would have been in July.
Yeah, and I tend to see an uptick around here when we kind of get into those northwesterly flow patterns, if you want to call them that, where you've got storms firing up to the northwest you and coming down, and the classic I always see around here is they come down 64, and then it seems as they hit Richmond, they actually curve with the river. And usually when they do that, they tend to draw in some kind of little extra, since I guess they're backing against some kind of winds aloft. It spawns some kind of spin in the storm. And more than once, I've seen a tornado warning issued right here in the city, in the metro area, with one of these storms. It's just tracking southeast, but then it likes to start tracking a little more south. I'd like to find a way to go back on some of those days and look at the setup to see if there was some kind of a wedge front that I wasn't aware of sitting north of town. And because it was north of town, I sat in the sunshine all day and didn't realize there was a wedge up north to see if that's what caused some of those storms. But that's the pattern I typically see come June, July,
right,
even early August, is storms from the northwest are the potent ones. You don't get as many southwest to northeast storms around here this time of year, I don't think.
Right, and I think you're right. I think it doesn't take much if you got the right dynamics. That time of year, there's plenty of CAPE available.
Yeah,
and so I think it may be even there in Richmond, because right along the fault line there, you might even be able to be seeing a little bit of sea breeze interaction.
Sea breeze, or maybe even some kind of uplift from any surface winds coming from the east, kind of hitting that terrain bounce and just kind of shooting up in the air a little bit.
Right. I say sea breeze. It could easily be a bay breeze too, off the Chesapeake.
Yeah.
But yeah.
Because I think I saw something the other day. Somebody was analyzing either a tornado warning storm or a tornado that actually happened up in New York, or just a environmental setup. And they did a cross section of the wind profile around the Hudson Valley and noted how the winds going up the Hudson Valley created a boost in the shear in that area. But it was very low level because it was just the winds down in the valley, but they were added at least 10 knots of shear to the environment, just the low level environment, just in the valley area. So if a storm tracked across that, it could have fed off that a little bit. So not that we have great valleys around, comparable valleys around here, but small scale things like that could play a factor, and fall line could be a perfect example of that. But
yeah, and that jives with some stuff I observed when I was chasing around Fredericksburg. In fact, I actually wrote a paper that I never published, but I kind of put it together and did a little bit of research on case studies on several storms that I noticed that had spin ups, whether it was a funnel or a tornado that spun up real quickly in the Rappahannock River Valley. Because there, of course, at the fall line in Fredericksburg, it widens out very abruptly from a kind of a rather, I say steep, but a couple hundred feet of relief, and it all of a sudden broadens out to several miles wide, and you have this channel that snakes down toward the bay, which does funnel southeast winds up that way.
Yeah.
So you get one of those setups, and like you said, it doesn't take much to enhance that low level shear to make something spin up. And of course, in Fredericksburg, you're basically below the radar horizon of either Wakefield or Sterling.
Yeah. So yeah, it's struggling to get that real low level view of the storm.
Right.
I was just looking at some of these other models here, just looking at the 0 to 1 shear or helicity, just to kind of see what was going on. Yeah, it's kind of typical for around here, a little anemic. There's no real good environmental push to get the helicities up. It's only about maybe 100, 150, which nothing to sneeze at, but certainly not in the ballistic category of worry for tornadic storms. But
right.
But that that's typical for around here in the summertime. The storm dynamics that increase helicity, and up in New York and upstate New York, it's 300, 400 in the 300, 400 range. But you're closer to your low pressure up there and your frontal boundaries, or where your warm fronts and cold fronts are coming together. So that would be expected. This far south from the main dynamics, this is what you're used to around here in the summertime.
Yeah, I mean, you kind of you deal the cards with the cards you got played, right? But again, I think it's, if you got enough cape, it doesn't take too much perturbation of anything else to create some additional spin for you. In fact, you talked about helicities. I was looking at this from the. Let me see if I can screen share this here. Let's go back here. This is from one of the WRF models, and it's the 0 to 1 helicity. And if you watch, this is at again 21Z, but it kind of maximizes there almost over Roanoke, and then spreads out a little bit. So
I almost wonder if it's picking up on an actual storm developing there, and
right.
Because that's what was interesting about the storms last, was it Thursday or Friday? Friday.
Right.
The HRRR, I think on the 18Z HRRR, it picked up on that storm and went absolutely bonkers with that storm. I mean, it had a SIGTOR value of probably 5 or 6.
Wow.
Following that storm into Richmond, going down the James River between Richmond and Petersburg. I mean, it was, if that had come to fruition, I mean, that was just a red light. We got a problem, and I think some of the local weather people saw that and kind of went, luckily, it didn't come to fruition, but and just the way that storm was developing, and I was watching your stream and watching the WDVJ7 live cast of the storm. That storm looked impressive on radar for a while there, so I could see why the HRRR picked up on that and said, "Oh dear!" And if it was just going to chug along that boundary, with the helicity, it had helicity probably pushing 300, 400 meters squared per second squared.
Right.
So it's interesting to watch how these high resolution models can pick up on individual storms like that, and in the storm scale environments, and almost track an individual storm like that, and not just issue a blanket. This whole area is favorable for tornadoes. It's saying, hey, this storm right here is going to be, sitting in a prime area to rotate and potentially produce tornadoes. So I'm not
Yeah.
seeing that here, but I haven't quite seen that with any of the short range models. But it'd be interesting to watch the HRRR tomorrow to see if it does anything similar to that.
Yeah, and that's what I'm going to do is I'll watch in the morning and see if it picks up on anything specific. And then of course, like I did last Friday, basically I occasionally would check on the HRRR, but most of the time I was just watching surface obs and satellite. Where's the front? Where's the dynamics? And I saw that one cell that was slowly moving northeast through Franklin and then Bedford County, and I was able to get ahead of it, or at least get on the east side of it. And that was it. I mean, and it'd be interesting to do some case studies on this. If we'd have to get somebody to pony up some money to do some real research. But to do like that particular storm, when it got near the front, it did intensify and turn right, but it also became extremely rain wrapped. I mean, it was to the point it was blinding rain. And I'm wondering if ingesting that much moisture that quickly because of the way the dynamics of the front, and maybe the angle of incidence they hit the front with, prevented it from doing what the HRRR was saying was, ride the front all the way down to Tidewater area.
Yeah, that'd be interesting to. I don't know if with it slowing down, if that just caused whatever precipitation that was going with it to just suddenly kind of stop. I mean, you wouldn't think that the upper level winds would stop with the storm. It would keep ventilating the storm, but it would be curious. I think if I remember looking back on the radar, I think some small cells kind of developed around it as well. And that to me is usually the kiss of death of any not H or LP or standard supercells. If you get any kind of storm that develops around it and it ingests it, I feel like you lose them as a cyclone for a good hour almost until, as long as nothing else redevelops around it. Because I'll always remember a storm we chased in 2010 with the Hokie Storm Chasers at beautiful supercell just north of Amarillo. And unfortunately, a little cell popped up on the back end of it and
choked it
got
off.
ingested, and we lost the wall cloud for a good 45 minutes. And that there was a brief tornado reported. I don't know if it was during that time frame or not, but the storm never regained its classic characteristics after that. It turned into a massive kidney bean rolling across going north of us. So, I mean, it still looked impressive, but you just, unless you were sitting in the inflow notch, you could not see the mesocyclone or anything like that anymore.
Right. And I know that the last Friday, the chasers that were east of the storm, further east than me, there were a lot of people that kind of positioned themselves along 460 east of Lynchburg, like all the way toward Appomattox. They caught sight from a distance of the wall cloud that I was tracking. But once it hit that front, everything it rain wrapped within probably a few minutes.
Wow.
And it just kind of is tightened right up. I had to reposition because I was in rural Bedford County, so I had to work my way back up toward 460. And by the time I got anywhere near 460, you couldn't see anything.
Right. Yeah. And that's the perils of chasing around here. Is the road network gets you, and unless you just happen to play the cards just right, and if getting yourself in good position somewhere is going to take you out of good position somewhere else. So you're just kind of hoping when you get to it and you see it that it does what it's going to do, and you can see it. But
yeah. And if I had realized it was going to turn right when it turned right, I would have taken a different route, and I might have been able to stay just south of it. But it's you don't know at the time. Especially when I was chasing solo. I was navigating and doing all the stuff.
Right.
You know what that's like.
Yeah. And when you can't see the boundary that well defined, you're exactly right. It's hard to see. Down towards Wakefield at that time, the boundary is actually showing up on radar. But when you're that close to the radar, it's a lot easier. I think from about Smithfield to maybe Disputana, the boundary was showing up, and it was still pushing south throughout the day. So that's how I was trying to judge where the storm was going to try to eventually make it down this way. But I think the storm fizzled before it even got to Farmville, or it was certainly below severe limits and didn't look that impressive on radar. And there was another batch of storms coming up from the south, but and that the front just kept pushing further and further south. So my chances for chasing anywhere around here in Richmond were just dwindling by the minute as that front sagged south.
Right. And then unless you do have a view of radar, or you got a second set of eyes in the car or in the vehicle, somebody that can watch surface obs and satellite,
Exactly.
You're pretty much doing eyeball stuff. Mark 1 eyeballs, all you got.
Yeah, and around here the surface obs are that we have aren't as numerous as when you get in Oklahoma to really be able to pinpoint stuff. You probably have a surface ob in Lynchburg, and you probably don't get another one until you're either in Charlottesville or maybe somewhere in between. But
yeah, I think there's one in Farmville that reports.
Mm-hmm.
But you're right. Yeah, it's not very fine. I'll put it that way. It's pretty coarse.
I'll try to use sometimes the Wonderground map, and with everybody's personal weather stations, and you can sometimes try to make it out on there, depending on how accurate those things are. If you look at the wind barbs on that, you can sometimes see where boundaries are. Not super defined, but if you're really struggling to pinpoint a boundary, that's always a fallback for me, just to kind of see what's going on.
Right. Well, as far as tomorrow goes, I think I'll probably refine my chase times after taking a look at the 12Z, at least the short-term models tomorrow.
Mm-hmm.
I'm thinking that I probably, as a matter of fact, I've got you remember you met Nick Gilmore? Did you know Nick?
The name rings a bell.
He was a Hokie storm chaser, and he works for public radio here in Roanoke. And he's actually going to chase with me tomorrow and kind of do a story on storm chasing, I think.
Okay, cool.
So anyway, we're going to rendezvous. We're supposed to rendezvous about 2. I may adjust that depending on the convection, but I have a feeling that we're going to be done before dark. I think this looks like this thing is going to push out, and once it gets past about 6 o'clock, unless there's some 6 o'clock magic,
yeah. Mm-hmm.
I think once it gets back east of the 29 corridor, it's going to start fading out.
Yeah. If with those 700 millibar temperatures that high, it's going to need daytime heating to survive, and once that starts dwindling away, I don't see these maintaining any strength into the night, at least not with limited forcing and dynamics like that. It'll be a boom during the peak heating, but after that it'll bring some welcome or unwelcome rain depending on where you are around here.
Yeah, and looking at some of the soundings I was checking, the dew point temperature spread is not that wide, so LCLs will be relatively low, which of course you think for a spin up that could be good, but of course here in Virginia with the trees and the hills, that does make it difficult to keep track of the base. Yeah,
for visibility and storm structure views, that's it depends on what you're looking for. If you're looking for the tornado, that's good, but if you're looking for some good storm structure, it's usually not the best. But
right, and of course, then you throw in what we were seeing dew points in the mid 70s or something. So you're probably talking heavy rainers too, because I doubt the jet stream level winds are strong enough to ventilate it very well.
Yeah, and let's see if I can get the P-watt values here. I'm sure they're in excess of an inch. Yeah, we're looking at close to 2 inches, especially if you get further east. So
yeah,
there'll be some downpours, that's for sure.
Yeah, so
just what we need.
Exactly, more rain. Whoa.
I crossed over the Pamunkey River today on 360 heading to Tappahannock, and it was the highest I've seen in a long time. There were some power crews trying to string some new power lines down there, and their little giant pallets that they use to drive across wet ground were just floating in the water down there. So they weren't getting a whole lot of work done.
Yeah, I can imagine. So, all right, well, we'll wrap this up for a discussion about tomorrow. It's it's again, it'll probably be. My guess is there will be a slight risk issued for the mountains and maybe Roanoke to up to I-64 kind of area, but I think marginal risk might get tugged a little further east, and that will be basically for straight line winds. I think you're gonna get some wet downbursts as these things kind of rain out.
Yeah, I think the general dynamics are there for it. Whether the coverage will be there to get it, that might float. To me, it might float on that boundary just based on some of the reflectivity models here. But I certainly think towards Richmond, we wouldn't do anything more than a marginal, unless the overnight models all of a sudden just go ballistic. But
right. And what you might get too is if they hold together long enough and it start and as dark approaches, you might get a good lightning show off to your west.
I'll take that. I'm always down for a good lightning show. I got a great view out this window behind me to the west with relatively unobstructed, so I can see some good lightning shows from there.
There you go. All right. Well, we'll sign off for tonight, and we'll see how things go for tomorrow.
All right, good luck out there. Hopefully you can, whatever fires you can catch out there, and if they got enough energy, send them my way, and I'll pick them up from there.
And we'll do that. All right. Here we go. Let's stop it off here.